Hello folks, in this video I will try to explain about the summary of neutron interactions. Okay. So this is especially for neutrons. So what happens if you have neutron? It hits a nucleus. Okay. So there are 5 types of neutron interactions, which are the elastic scattering, inelastic scattering, radiative capture, projectile capture, and fission. Okay, so I will start with the elastic scattering. Okay, so it is called elastic scattering because of the total kinetic energy before the collision is the same with the total kinetic energy after the collision. So the kinetic energy before and after the collision is conserved. Okay. Similarly, the momentum before the collision is equal to the momentum after the collision. So momentum is conserved as well. So to imagine the process, let's say this is the incident neutron. Okay, this is the target nucleus. Okay, so the kinetic energy of the neutron, okay, let's say, okay, so let's give the name for the mass of neutron, mn. Okay, its velocity is vn. Okay, and this is the mass of the target, mt. This velocity of the target, mt. Okay, this is before the collision. Okay. So and after the collision, okay, let's give it actually this is 3 picture. Okay, what I shown here are 3 different picture. Okay, this is the first picture, which indicate the situation before the collision. This is the second picture. This is the third picture. So second and third pictures is referring to the 2 possible ways of how the elastic scattering will end. Okay, so there are 2 ways. Okay, so the first one is the neutron is absorbed. Okay, so when the before the collision, neutron enter the target nucleus. Okay, so the neutron is absorbed. Okay, so when the neutron is absorbed, okay, the nucleus, okay, the initial nucleus now become compound nucleus. Okay, so it is called compound nucleus. Which is why I put star or asterisk at the top of the nucleus. So this compound nucleus is at an excited state. Okay. And after a moment, okay, to return to the ground state, okay, to return to its ground state, so this nucleus, okay, emits a neutron, okay, and return to its ground state. Okay, so that's the first way. The second way is occurs without the absorption of the neutron by the target nucleus. Okay, so it's just like the billiard. Okay, if you it's like the interaction between two ball in billiard game. Okay, so after the collision, the neutron scattered to one direction and the target nucleus scattered towards another direction. Okay, so uh, so in either way, okay, as long as the the total kinetic energy before is the same, okay, in before and in after the scattering, then the process is called elastic scattering. Okay, so I given the name mn and mt for the mass before the reaction. Okay, and let's say after the reaction, after the scattering, so mn remain mn. Okay, mt uh, still remain empty. Okay, and but the velocity could change. Okay, so v n dash, this one is v d dash. Okay. So so in mathematical equation, okay, m n v n 1 over 2 mn vn square plus 1 over 2 mtv e square. Okay. Those for the total kinetic energy before the collision is equal to the 1 over 2 m n vn dash square plus 1 over 2 m n v t mt sorry mtvt dash square. Okay. So the magnitude of velocity, okay, might change, okay, for the neutron and target nucleus, but the sum of the kinetic energy before and after, if it remain as before the collision, then the reaction is under the category of elastic scattering. Okay, so either the neutron is absorbed, okay, or not absorbed. So this is the elastic scattering. So opposite to the elastic scattering, we have inelastic scattering. So the kinetic energy is not conserved. Okay, but momentum is always conserved. Okay, so only the kinetic energy is not conserved. So meaning that the net, the total kinetic energy before and after the scattering is not same. Okay, so this is okay. Again, this is three different picture. Okay, so this is the incident the incident neutron. This is the target nucleus. Okay, so during the inelastic scattering, okay, the neutron, so this neutron will be absorbed into the target nucleus. Okay, and then compound nucleus is formed. Okay, so compound nucleus is formed. Okay, and after a moment, okay, this compound nucleus wants to return to ground state. Okay, because the compound nucleus, okay, immediately after it absorbs the neutron, it is at uh, it is in an excited state, so it has excess energy. Okay, so it wants to return to the ground state. So how how can that how is that possible? That is possible by uh, re-emitting. Uh, that is possible by emitting an electron. Okay, so new electron is born. Okay, recoil to one direction, and the excited state nucleus recoil to another direction. Okay, and this excited state nucleus is still not reaching the final ground state. Okay, so it emits gamma ray, okay, to return to its final ground state. So this is so finally at the end you have the ground state nucleus and gamma ray. Okay, in the middle of the middle of the process, okay, uh, the compound nucleus, okay, has so much energy, okay, much higher than this compound nucleus. Okay, so that energy is enough to emit a new neutron. Okay, so this neutron is not the same with this neutron. Okay, this neutron is the newly born neutron. Okay, this is the incident neutron. So both they are not the same neutron. Okay, and after the final stage, okay, the third stage, okay, at the third stage you have the ground state nucleus. Okay, this one, gamma ray. Okay, so if you sum up the kinetic energy, okay, so the kinetic energy of this target nucleus, okay, kinetic energy, one over two m t v t dash. Okay, so the for gamma ray, let's say the energy is E gamma. Okay, and then the newly born neutron is the kinetic energy is 1 over 2 m mn vn dash square. Here I forgot the square. Okay, so after the at the end, after the scattering occurs, okay, you now have three different entity. Okay, neutron, the recoil neutron, the recoil nucleus, as well as gamma ray. Okay, so if so what is meant by kinetic energy not conserved is that if you mathematically, okay, shows it, so before the collision you have 1 over 2 mn v n square. Okay, target nucleus 1 over 2 m t v t square. So if you try to balance the equation, okay, the conservation the conservation of energy, it will look like this: the kinetic energy of the incident neutron, kinetic energy of the target nucleus. Okay, so this is the total energy before scattering, before the collision. Okay, and here is the kinetic energy because you have the recoil neutron, so that mn v n dash square. Okay, then you have the recoil target nucleus 1 over 2 m tvt dash square s plus the energy of the emitted gamma ray. So if on the left hand side is the total energy before the collision. Okay, and the right hand side is the total energy uh, after the collision. So if you only consider the kinetic energy before and after, okay, then there is excess. The right equation and the left equation is unbalanced the because of the energy of the emitted gamma ray. So what what can we say here is that part of the kinetic energy before the collision now change to the gamma ray energy. So in conclusion, we say that kinetic energy is not conserved. Okay. So the radiative capture, as the name given, as the name given to the process. Okay. The incident neutron is captured. Okay. Forming compound nucleus. Okay, so this compound nucleus is at an excited state. So it returns to its ground state by emitting gamma ray. So neutron is captured. Okay, neutron is captured and then radiation is emitted. So which is why it is called radiative capture. Example here, uranium 238 absorb neutron, okay, forming excited state uranium 239. Okay, and then this uranium 239 return to the ground state of uranium 239 by emitting gamma ray. Okay. For particle ejection, okay, so instead of emitting gamma ray like in the radiative capture, the particle ejection is ejecting a particle. Okay. The obvious example is when you bombard boron with neutron. So the compound nucleus is the boron 11. Okay, that returns to that decay. Okay, this one is decay. Uh, it has no choice but to decay according to alpha decay. Okay. To end with a stable state or the ground state lithium 7, okay, as well as emitting gamma ray, emitting alpha particle. And finally it's the fission, okay, which the target nucleus absorb the neutron, okay, forming compound nucleus, and after that the compound nucleus splits into two different nuclei. Okay, so so scattering reaction, under scattering reaction we had elastic and inelastic, and under the absorption we have radiative, projectile capture, and fission. Okay, so I hope so. That's the overview. Some overview about the interaction of neutrons with nucleus. Thank you.